Rome wasn't built in one day, and it wasn't due to poor planning or rainy days. It wasn't built in a day because of the technological advancements happening at the time. Three main advancements in technology are the roads in Rome and how they created ancient concrete, the Bessemer process and how steel was made cheaper and faster, and the most recent, artificial intelligence and how it can speed up the process of pre-construction and planning. The Roman roads were one of the main reasons Rome grew so large. They spanned from Portugal to Syria and England to Egypt, covering all of Europe and into the Balkans. They allowed transportation of goods and troops. They would move their troops faster than their enemies and be able to support them just as quickly. These roads laid the foundation of how we build roads today. They dug ditches alongside the roads for rainwater retention, added curbs to prevent dirt washing into the roads, and added mile markers every Roman mile or 4,850 feet. This image not only shows the information from the previous slide, but also how they built the roads. They would dig 6 to 9 feet deep and use that dirt to level around 3 feet. Above that, they used compact sand to ensure it was level. 10 to 24 inches of crushed rock was the next level, followed by 9 inches of pottery shards and stone and a lime mortar. They would top it off with their iteration of concrete and sometimes large stones and a lime mortar. Ancient concrete is not far off from our modern day concrete. The Roman used small gravel or sand layered with lime, which in itself formed a strong bond. They would often mix in pottery, brick shards, and volcanic ash to make it stronger and even waterproof. In the early 1800s, there were two types of steel: cast iron, which was used as decorative facade panels and internal support columns, but they often caused catastrophic failure under tension or bending forces. Wrought iron, which was strong in tension, but required the puddling process, which is where workers stirred pig iron in a furnace to burn off carbon in small 100-pound batches. Since strong steel was so expensive, most buildings relied on brick, load-bearing walls. For multi-story buildings, the first floor walls would get thicker and thicker to support the load. This caused buildings to take up sidewalks and even road space. This was all fixed in England in the mid-1800s by Sir Henry Bessemer. Bessemer's process used pressurized air to remove carbon impurities, allowing a long day process to be completed in 20 minutes. The rapid oxidization generated intense heat, which in the long run used less energy. At the end of the day, Bessemer's process gave everyone stronger and cheaper steel and was the leading factor of the construction of skyscrapers. With construction moving towards being more computerized in today's age, with things like BIM and Bluebeam, it is safe to assume that AI will soon take over. AI has already been found to evaluate thousands of logical paths in the span of seconds. A project manager typically uses their best guess. AI has been mainly used to find errors known as clashes. Hard clashes, for example, a 12-inch main plumbing line running directly through a structural steel beam, and a soft clash, which is for things like high voltage electrical boxes being placed too close to hot water pipes, which violate building code access space. AI can do so much more, and it still continues to grow. In conclusion, construction is never static, and the speed, safety, and scale of what we can build keeps moving forward. Thank you.